In this lecture segment, we'll debug the just written tabs version 5 example and learn a bit about debugging web apps. Picking up from the last segment, we need to figure out why our mouse clicks are being ignored, and more importantly, we need to look at various tools and approaches for debugging web apps in general. As we walk through the debugging session here, follow along with your own copy of tabs v5. Make the debugging changes that I'm making, and use the Chrome debugger as I am. You'll find these tools useful for projects you're going to be doing moving forward. Now, it may be old-fashioned, but developers still use debugging print statements. In Chrome, the earlier mentioned console object lets you print to a console screen in the debug window. Let's confirm that we're getting the tabs set up and that we really aren't reaching the click handler. I'll add console.log statements here to the JS file, the tabs v5.js. Let's kind of outdent them so we can see them as debugging things. And again, do the same yourself so that you can kind of lock this stuff down rather than just looking at what I'm doing but not trying it yourself. Okay, so there's one for each step through the loop that does a setup of a tab. And then we'll put one down on the click handler as well. Just have it say click. Now before I run these, look up inner text and predict what that first console log on line 19 will be printing. Coming back from a pause, the inner text property gives the text inside a tag. So we'd expect, for instance, tab 1, tab 2, setting up tab 1, setting up tab 2, and so on. Okay, with that in mind, then let's reload the app so that it runs with the console log statements. Should we save that first? And what we'll find, if we bring up the log window here, is that we are reaching each tab in setup as the log window indicated, but all the clicking in the world up here does not result in a click exclamation point message. Now, if we want to avoid console.log statements, we can instead set breakpoints in the debugger. You do that under the sources page here. Get rid of the console for a moment. This thing works with breakpoints and debugging information. So we can put breakpoints, say, on line 18 there, and maybe line 25, and rerun the script by refreshing the page again. And we hit the breakpoint at line 18, as you can see. And we can continue execution by clicking this Start-Stop button here, and step thus through each iteration of the setup loop. Maybe we should bring the console back so we can see that that's happening. And there's one. There's the next one. We're just going back around the loop to hit that breakpoint again and again. Okay. By the way, tooltips on these other debugger buttons will tell you what's going on. I'll let you explore those on your own. Now, if we're getting tired of that breakpoint, we can just clear it and resume again, and we should just run through the rest of the loop. And so again, though, clicking on the mouse doesn't do anything, even though I did have that breakpoint down on line 25. Okay. Well, maybe the event handler is messed up in some way. Let's do several different confirmations of the event handler configuration. First, let's look at the bottommost entry in the Elements page here of the Chrome debugging window on the right-hand panel. And this is the one that showed you style information, as you may recall. So along with style data about a given control, we also have down near the bottom several other sections that will show you, for instance, the details of the CSS box that the element in question has under metrics, or the particular properties of the DOM object under properties, You can expand each of these different levels of properties. And then importantly, a list of event handlers or event listeners under this tab here. Now, there are no event handlers for most of the divs. The block 1 div we're looking at, for instance, right now has none. But if we drill down to the tab, for instance, tab 1, we do find there's a click handler shown. If I expand that, it has a link back to the relevant source in our JS file. So it looks like the event handler has been registered. Another good debugging tool for events is under the sources page we looked at a moment ago. Down near the bottom of the right-hand debugger panel is a section that lets you specifically set breaks as events occur, this event listener breakpoint. All of the events are in there in groups, and expanding the mouse group, we find the click event on which we can set a breakpoint just by checking it. And still, though, there's no result when we click on the tabs. So there's one final check we can make. Some events can be programmatically generated by calling a function of the target element rather than by UI action. And the click event is one of these. Calling the click function on any tab element will have the same effect as actually clicking the mouse on it. So let's do a click call in our code and put that just after the event handler is set up. Thus, and then we'll run it by refreshing the page. But before we do, question 2, find 2 other events that can be artificially generated this way. And by the way, don't be confused by the on-click, on-blur, etc. properties of element objects. Those are like the window.onload property. They're a means of setting up an event handler, not a way to cause the event in the first place. So coming back from a pause where I presume you did a little bit of research, blur and focus are 2 other examples, and generate blur and focus events respectively. When we rerun the code now, we do finally get our handler called. The break at line 21 here is due to the event handler breakpoint on the right-hand panel that we set down here. Continuing past that, we get the click message, as you can see, and then the breakpoint at line 25. Moving past that, we get the event breakpoint for the next tab, and so on. So we're getting events programmatically generated, at least. Let's clean things up a bit here. Clear the source code breakpoints, which I can do right there, actually. And let's go and modify the source code, which you should do in your copy as well, to get rid of the console log calls. And that leaves us with just the mouse click handler here, the debugger's click breakpoint. And now let's figure out why our physical mouse clicks are getting ignored when the programmatic ones work fine. Now, event handling can be tricky in the presence of a deep hierarchy of divs, as in our example. The details are complex, and the bibliography does include a deep discussion of them, but we'll explain the general idea here. First, note that when you click a tab, you're not just clicking on that element, you're clicking on the entire page. And on the parent block div, kind of walking down through the hierarchy here, and on the tab block div, and on the row div as well. And this is because the tab, of course, resides within those parent divs. So which one gets the click event? This same issue frequently appears in other GUI systems, since hierarchically organized UI elements occur in almost every GUI. The usual approach and this is true of DOM events, is that the UI system drills down into the hierarchy from top to bottom, calling event handlers, if there are any, on first the parent element, then the child, then the grandchild, and so on. This gives parent elements the chance to adjust or even intercept events before they reach the child elements. Then the event processing goes back up the chain, from descendant, or child, back up to parent. This lets child elements choose either to process the event or pass the buck back to their parent element. By using parameters of add event listener that we're currently just ignoring, you can set up event handlers to intercept events in either direction, the downward, or capture phase, as it's called in DOM design, and the upward, or bubble phase. Other GUI systems, by the way, have different terms for those concepts. Now, for many events, this is way too much detail, since only one element in the hierarchy even registers an event handler at all. In our simple app, for instance, only the tab div has a click event handler. If you want deeper information than this very brief intro, just type DOM event flow at Google. But it's worth being aware of this event handling chain, not least because sometimes it screws you up in subtle ways. Let's see what happens if we just move some of our tabs up out of the hierarchy near the top of the DOM tree. This simple test is a good way to be sure you're not getting messed up by event flow. We'll adjust lines 8 and 9 along with, well, let's first move the tabs here. We'll put tab 1 up at the very top level here, and tab 2 just inside the block 1 div, and we'll stick tab 3 just inside the tab block, like that. Then again, try that yourself, please. Then we do need to tweak the JS file a bit as well. First, let's drop the extra click call there. Don't need that anymore. And we need to adjust lines 8 and 9 up here so that they get all tab and page styled divs no matter where they are, since some of them are no longer under the tab control. And in fact, question 3, how do we adjust lines 8 and 9 so that they pick up tab and page divs wherever they are, not just under the tab control? Coming back from a pause there, really the simple thing to do is just replace tab control with document. Since document is a global and it's always available, and it will reach everything in the document. So now, with just our one debugger breakpoint for click, as you can see there, and by the way, be sure to have the disable breakpoints button off. If it looks like that, that's wrong. That'll turn off all the breakpoints temporarily, including the click one. You have it look like that. And with that setup then, and with a reload, if we click tab 1, it works. We get paused at the click handler. Trying tab 2, breaking that or continuing that pause, also works. And note, assuming we continue on here, that the selected page changes as well, as expected. We can click back and forth between tab 1 and tab 2, and the page changes with them. But tab 3 doesn't work. So something's up with the tab block div. But before we go on, we pulled tabs 1, 2, and 3 out of the row div, as you may recall. Thus. So they all still show in the same position that they did before. Why is that? Reason this out based on flow layout rules. You may find it useful also to mouse over these 3 tabs in the debugger elements page. And after a pause, they are being laid out one after another. There's tab 1, for instance, and then tab 2, and tab 3 based on the standard flow rules. The back row div has no content. You can see that if you look closely there, it has a 0 pixel height. So it doesn't affect the layout at all. And then tabs 4 through 6 are in a row div, which has a clear both, so they go on the next line. So, what's wrong with the tab block div? For some reason, it's keeping tab 3 from being clicked. Now, here it just comes down to thinking carefully, and in particular, looking over the CSS for tab block, we might reasonably wonder about that z-index of -2. So, let's put our tabs back where they belong now. Let's remove that z-index. And going back to the example page and reloading it here, we do find that the back row is obscured. Recall that that's why we had the z-index at -2 in the first place. But clicks on tab 4 and on tab 5 and on tab 6 now work. So what exactly happened with the z-index? The tabs were all visible. Wouldn't the click event reach them? Think about the event flow. In the capture or downward phase, the event handler starts at the top, at the entire document, and then it goes down into the block 1 div. Well, so far so good. But the tab control, or the tab block div, is behind the block 1 div by virtue of its z-index being -2. And so the event capture stops there. The fact that the children of the tab block div are visible doesn't save them. The event capture stops at their parent. Now this would be more obvious if the block 1 div actually had content, like say a solid color. Then it would be more obviously obscuring the tab block. But in any event, that's the problem. So, speaking frankly, is this a pain in the ass? You bet it is. But the good news is that not all DOM bugs are this nasty. The main reason we've been through this discussion is to introduce a lot of different debugging tools and methods. So summarizing those. First, the elements debugger lets you walk through the DOM tree, seeing how elements are positioned on the page, how their style was determined, and what properties, including such things as event handlers, they have. Thus. Console.log, number 2, lets you print arbitrary information for debugging. The sources page lets you set line-by-line breakpoints or specialized debugger breakpoints for specific events. In fact, we'll turn off the click now since we don't need that anymore. Certain events can be programmatically generated, which can help with debugging them. And then point 5, deep knowledge of event flow can wait until you have need of it, but you should be aware of the generalities. And dinking around with the HTML hierarchy is a useful way to diagnose subtle event flow bugs. And so we finally come to question 5. Now that we have the bug isolated, fix it, and do so solely by modifying the CSS file. Test your fix before you proceed to the answer. Coming back from what might have been somewhat of a pause there, the reasonable fix is to leave the tab control at a normal z-index. And let's put the back row at z-index 1 instead, and the normal row at z-index 2. This sort of makes them, shall we say, stick out a little bit so that they receive the click events. And then saving that off and crossing our fingers here, we would hope that we now get consistent behavior, and so we do.